ओके सो हमें आज नया टॉपिक स्टार्ट करना था हीट। सो प्रीवियसली हमने साउंड कंप्लीट कर लिया हुआ था, साउंड टॉपिक का सारा पॉइंट्स कंप्लीट कर लिया हुआ था। आज हमें हीट स्टार्ट करना है, तो चले स्टार्ट कर लेते हैं। हीट बहुत इंटरेस्टिंग टॉपिक है। ऑलरेडी क्लास 8th में बेसिक्स आप देखते हैं, बेसिक्स जो है वो हीट का आप क्लास 8th में देखते हैं, बट यहाँ पर हम काफ़ी डिटेल में डिस्कस करेंगे हीट के बारे में, उसके क्या क्या पर्सपेक्टिव्स हैं, उनको कैसे यूज़ में ला सकते हैं, वो सारी चीज़ें डिस्कस करेंगे हम। ओके, तो पहले बहुत ही बेसिक सिंपल वे पे स्टार्ट कर लेते हैं। जैसे मैं स्टार्ट करता हूँ, लेट्स से मैं टॉपिक स्टार्ट करना हीट। सो फर्स्ट थिंग इज इट्स अ डेफिनेशन, व्हाट हीट इज। ओके, एनीवन, व्हाट इज हीट?
Sir, heat is a type of
The
energy.
type of energy.
Okay, further. It's not just the complete definition, because if I say the type of energy, so there are a lot of number of type of energies, na? So we cannot rely on the single statement that it is a type of energy. Something else which will elaborate more about what actual the heat is. Anyone else wants to add anything?
So it is transferred between objects.
Okay, that happens with the all sort of energies. Those can be transferred within the objects. Something
Sir,
else?
they get transferred through conduction,
Okay,
radiation.
so you are stating certain names. You are stating certain names that can be transferred through certain types. Okay, something
Sir,
else?
they flow from high temperature to low temperature.
Now that's a better thing. We are getting a new word which is called temperature. So I can say that heat is something related to the temperature. To define the heat, we need to define something about temperature. Someone wants to add more? Anyone else? Apart from the temperature word, I've got this word temperature.
Sir, it is measured in Kelvin.
It is measured in Kelvin. That's not okay. That is with the temperature, not with the heat. We want to discuss the heat. So we have two terms. It is a sort of energy, and someone is expecting it to relate it with the temperature. Yeah. Something else? Someone wants to add more? Achha, what it can do? Just focus on that. It is a sort of energy. I agree. Everyone agrees to that. It is a sort of energy. Now think about what it can do. What it can do. Think about it.
Sir, it can increase or decrease temperature.
So that is related to the temperature. Fine. So we have already discussed this, that it is related to temperature. What else? How else you can use a heat except the temperature word? What you can do? Just think, it's pretty simple, pretty obvious. What you can do with the heat? Can you melt down the object? Have you heard about melting?
Yeah.
Yes,
Change
sir.
state.
Yeah, so you can melt down the objects. So we can also rely on certain things that we can change the shape of the objects. If you do heat, keep on heating, the objects, their shape will change. Okay, so I can say that I've got a word which is related to the temperature, and then I've got a word related to some sort of change of a state. Now think about certain objects. Can you change their color also with the heat?
Yeah.
Not all the objects. What are those objects? Some examples. Whose color you can change by heating?
Sir, sugar.
Yeah, okay, fine.
Metal.
Yeah, all sort of metals, and there are a lot of chemical objects which will change their color based on the heating. So I'm not discussing a lot about those objects, those chemical substances. There will be a lot. I'm basically focused about the metals. Let's say any sort of metal, if you heat, they will change certain sort of colors based on their temperature.
Yeah.
Okay, so there are different things. There are a lot of things which a heat can do. So basically, I am saying that heat is a type of energy. So there are so many type of energies. You know, there are so many type of energies. Like let's say food. Food is also sort of energy, but every energy has a work to do. Okay,
Yes.
for what purpose it will be used. So I want to discuss what heat is actually and what purpose it serves. Okay, so
Sir,
let's, yeah,
sir, I have got one doubt
yeah,
when I was solving one paper.
yeah,
Sir,
yeah.
that question was the magnitude of acceleration of particle executing linear simple harmonic
Yeah,
motion.
Adit, what you can do, can you send that in the WhatsApp? We are discussing the heat and you brought the object SHM sound. Can you send
Yes,
it
sir.
on the WhatsApp now? It will be better.
Huh.
Yeah, fine. Let's come to that only. So let's see what about the energy then. So this energy, I was speaking of, yeah, energy. So food is a type of energy. There are a lot of type of energy. Every energy serves a purpose. Like I said, food, it serves a purpose. It gives a living body some sort of energies. Okay. So the same happens with the heat. What I explained, it serves certain purposes, which commonly are this one: temperature change, shape change, color change, and what else? It can be converted in other sort of energies also. So it is easily converted in other sort of energies. Okay. So these four things we will be discussing in the chapter. What? Number one. What is the number one?
Temperature.
Temperature.
To the temperature. Number two, how it affects to the shape.
Shape.
Number three, how it affects to the colors. By the way, we won't be discussing much about the colors. Like I said, it depends a lot about on the substances. So it is pretty theoretical term. You need to just learn which substance will give which sort of color on heating. Okay. Yeah. What is the fourth one?
State change. Convergence.
Convergence. It can be easily converted in other energies. Like how you can generate electrical energy from heat. A simple example: how you can generate electrical energy from heat.
Sir, in light.
Solar panels.
Solar
Solar.
panels. Solar
No,
panels don't convert heat into electrical energy. They convert sun energy, that's a solar energy, into the electrical energy. That is a different sort of energy.
sir, in a bulb.
In bulb. Okay, very good. So you are telling just the opposite part. In bulb, we convert electrical into heat, not heat into electrical.
Okay.
It's simple. A bulb, we give them
Ah,
electrical energy that
electric
converts
energy.
into heat and a light. Any method in which you convert heat into electrical energy. By the way, this is the most fundamental method to generate electricity. What I'm telling you, it is a knowledge factor. Uh, it is the most fundamental part to generate energy. Okay. Of course, not the generators. What happens? I'll explain how a commercial electricity is generated. Does anyone know how the commercial electricity is generated?
No.
Okay. Geothermal plants, sanskar. Okay, good. Okay. Uh, let's say every sort of energy, commercial electrical energy are generated from the heat only. What happens? I guess you already know the concept. What a generator does. A particular generator, you fuel it, you give it a fuel. Okay, there is some sort of motor that rotates and it generates current, electrical energy. Okay, that whole setup we'll be studying in class 10th, how a generator works. Okay, so that I won't be discussing now. But what happens, you give it a fuel, there is some motor, it rotates, and due to electromagnetic induction, it generates current. So that is not our concern. Our concern is fuel energy, we are converting it in current. But what is the thing which is converting the energy into current? This rotating motor. Okay, this rotating wheel, this is going to convert into current. So what happens? Every sort of electrical energy is commercially generated through turbines. What are the turbines? Have you heard of it? Turbine, anyone?
Yes, sir.
Yes,
They
sir.
are dams.
Yeah, exactly. In the dams also you will see turbines. Turbines is they are like a fan only. I'm not good at drawing the fan, but I'll say some sort of fan like this. It's not a regular one. See, like this. So it is a sort of fan. These are their wings. What happens if something hits this fan? They will rotate, and when they will rotate, like I said, there we use a technology EMI, electromagnetic induction. We'll be studying it in 10th. This will convert this energy into current. So this is a commercial method to generate the current. What we need to rotate the wheel, that's it, nothing else is there. We need to rotate the wheel, it will generate the current, electricity. Okay, now there are infinite number of ways we can rotate this wheel. One is
Yes, sir. Means in windmill also same process.
windmills
We just
also.
want.
You will see in windmills, uh, there is this fan. They rotate the turbine and generate the electricity.
Yeah.
Basic method. Now, what we can do, like I said, dam. Okay, someone told example of dam. What happens? The water comes from a height and drops on these turbines. Okay,
Hydroelectricity.
yeah, they rotate this turbine and again electricity is generated. Now, a best way to generate this rotate fan is some air. Now, from where you will find the moving air? You cannot find the moving air like so easily. So the best thing is to heat up the water. If you heat up the water, it will convert into steam and it will move and it will rotate this turbine. So the simplest way to generate electricity is to generate heat up the water, convert it into steam, and that will rotate the turbine. So like I
Sir,
said,
but
what happens
there
in
will be a
nuclear
lot
power
of
plant?
things to do to heat the water.
Yeah, so you will need something to heat up the water. Nuclear power plant also, there is a whole explosion inside it. Inside a chamber, explosion is made,
Yes, yes.
and outside the water is run so that it will convert into the steam. Okay, so like that, heat plays a very important role to convert it into electricity. Okay, so we'll be just seeing how a heat will be converted into electricity, how it will be useful. Okay, so these will be the 4 topics we will be discussing on heat. Everyone got those topics?
Yes, sir.
Okay, so then we'll be starting it. Okay, so let's start it, the particular part of heat. Okay, so let's just see heat. Now I can define simply, like I said, heat is a sort of energy which can be used. Okay, so like that I'll be defining it. It is a type of energy which is used to change the temperature, or state of object. State मतलब समझ गया, shape or state of object. State of object is not basically shape. State of object mean solid, liquid, gas state. Okay, so state of object means solid,
Liquids
liquid, and gas
and gas.
sort of a state. So state of object or shape of object and one more, color of object. Okay,
Yeah.
shape of object or color of object. Okay, so it is a type of energy which is used to change temperature, state of object, shape of object, and color of object. Okay, next, it is, like I said, it has certain types. Abhi, how many types have you heard of energy in work power energy?
Sorry.
In work power energy topic, you must have heard about
Yes,
this.
sir. Potential, kinetic.
Potential and kinetic.
Like I earlier said, these are the two major types. You can define
Yeah.
any sort of energy in this category.
Yes.
This also must have happened with the heat also. Okay. So heat lies on which part? Kinetic
Sir,
or
P में
huh?
sir,
Potential.
potential energy.
Okay, potential energy. How you can say it? Like
Sir, because heat is stored energy.
heat is stored energy. Okay. Something else? Someone wants to add more? Some of you are saying that heat can be related to the potential energy. Something else?
Sir,
Any more explanatory example you can say? Okay.
sir, but heat can also transfer, so it can be put in K also.
Okay, it can be put K in also. I need certain examples also on what basis you are saying it. So let's see first the example of potential. What is actually the definition of potential energy? Just tell me what is
The energy, the possessing energy of an object which is at rest, not moving.
something else. It is not just the only definition of potential energy. I guess
Energy of an object at a certain position.
okay, certain position is fine. You are going up to a one perspective, certain position. What else? Certain position I have marked. This is fine. This is correct. Can someone add more? It is related to position and what else? Two things are there.
Height,
Not height. Height means the position. Na?
mass,
Not
The
mass.
energy that is stored or conserved in an object.
Okay, sort of conserved and stored. Okay, that can be, of course, an idea. Stored
It
or
also
conserved.
depends on state.
State, sort of state, you can say. Sort of state. Okay, because solid, liquid, gas, they all have different sort of energies. Based on what? I'll say the actual term is called configuration. Configuration, what? It is configuration. So the potential energy depends upon two things. Certain position and configuration. Configuration can be related to the state also. So what I mean is every object has a different sort of configuration. Like I said, there is a pen and there is like let's say mobile. So both will have a different sort of configuration. Huh? So because of their structure only, configuration, what I'm saying, structure means configuration, they possess a energy which is called potential energy. So potential energy due to two things. Number one, height, certain position. And what is the second thing?
concentration.
Configuration. So which means the heat can be related to potential energy because it cannot change the position. That is fine. But what it can change?
Configuration.
Configuration. So it is related to what term? Configuration. So I'll write it like a chart. So it will be easy for you to understand that energy can be put in two parts. Okay, just let's see. Energy, it can be kept in two parts. Potential energy
Kinetic.
and kinetic energy. Okay, now there are two terms. With the potential energy there are two terms, and with the kinetic energy also there are two terms. What are those? Potential energy is related to number one, position,
Yes,
and
and
second,
configuration.
exactly, it is related to configuration. Configuration means a proper structure. Okay.
Structure.
Okay, now what about the kinetic energy? Like I said, kinetic energy is defined with the object moving. Okay.
Yeah.
I can say it is motion of object.
Yeah.
Motion of object. And one more thing is happening at the molecular level. If you see, or you must have been told, suppose there is an object. Okay, there must be some atoms.
Yes.
Okay, so are they at rest?
No, they are always moving.
Moving in what manner? Like, can they go somewhere else? Can they
No,
leave this
but
object?
in that frame only.
In that frame only? What sort of motion they make?
Transverse wave
Like they vibrates.
Okay.
Okay, the molecules inside any material or any object, they vibrates, they are in the motion. So is the whole object in motion?
No.
No.
But their molecules, they are in some sort of motion. Got the idea?
Yes, sir.
So that means there are two things with the kinetic energy. One which you can see, which is the motion of object, and one which you cannot see. Clear? So the atomic level or molecular level that you cannot see, but there is the energy, there is kinetic energy. All the molecules of an object, they vibrate, they have some sort of kinetic energy also, that which you cannot like see, of course. Okay, so like I said, position you can see, but configuration, it's like tough to observe, it will be different. Same happens with air also. uh, Motion of object you can observe. What you cannot observe is the molecular motion. Okay, so kinetic energy is related to two terms. Number one, motion of object.
Motion and molecular.
Yeah, molecular motion I can say.
Yeah.
Or motion of molecules. Motion of,
Sir, then it will be okay to write molecular motion only. No?
yeah, molecular motion. Motion of molecules or molecular motion. Or good thing
Same
is
thing.
the motion of object, it is easy to see. Easy to see. But molecular motion you cannot see.
Difficult to see.
Yeah, matlab we cannot observe in a normal way. Okay, so we can see with naked eyes. Okay, so we cannot just see them by our own eyes. So
Can't.
yeah, we can't. Okay, we can see with naked eyes. So motion of molecules, what sort of motion they are making, of course you cannot see, but the scientists have discovered which sort of motion they are making. So you will be amazed, they can make all sort of motion. So further, when you'll go higher in higher classes, you will be told that the molecules vibrate. But do they only vibrates? No. What happens with the gas? With the
They
solid,
move in any way.
in they can also move, na. Not just they vibrate. They can
Yes, they can move in any way.
yeah. And one more thing comes there. They can also rotate.
Rotate.
Yeah, they can also rotate. Of
Okay.
course, a single molecule, for a single molecule, single atomic molecule, it will be not observable that it rotates. But if you see a double molecule, let's say I take H2 with the hydrogen, then hydrogen gas if I take. So each
Yes.
molecule will have two H atoms.
Yes, then
Now they will be rotating.
uh,
They will be rotating. So that
they
one,
will look like dumbbells.
yeah, exactly like a dumbbell. Of course, not exactly like a dumbbell. That's just a representation, but yeah. So motion of molecules, motion of object, it is clear. And the good thing with the motion of molecules, though we cannot see it, but we know which sort of motion they can make. So it's obvious to write all sort of motion, all sort of kinetic energy is possible. So all, or I'll write translational, rotational, and vibrational motion. Okay, so this sort of motion is possible with the molecules. Okay, so motion of object I am not dealing because we have already studied in earlier ninth. Okay, what sort of motion an object make, that we, you, everything. Okay, but if you cannot see it, how you will judge whether they have more kinetic energy or not? The problem with this term is because you cannot see it, so how you will observe? So the term is See, the physical term which is related to molecular kinetic energy is the temperature. Of course, you cannot see it whether they are having more energy or not, but which term is going to tell you about that, whether they are having high energy or not, is temperature. Okay, high temperature means higher molecular kinetic energy. Clear? I guess this is now okay with everyone, that we
Yes.
cannot see the molecular kinetic energy, but by some justification we can say that the temperature will be saying about, if its temperature is high, that means it is having higher molecular kinetic energy, and if the temperature is not changing, that means the energy is not going
Is
towards
lower.
kinetic energy. Okay, so up to this point all the things are clear related
Yeah.
to potential and kinetic energy. Okay, so like I said, heat is related to this one, and heat is related to this one. Now, how we measure the heat? What is the unit of heat?
Kelvin.
You already know, not the Kelvin. It's not the unit of,
Joule.
it's a sort of energy, yeah. So it is a sort of energy. So of course its unit will be joule.
Joule.
Its SI unit is joule, like other energies. Okay, okay, अभी problem देखें, what is the actual problem, that we do not use the term joule in like our calculation. Of course it is a SI term. Whenever like we conclude this heat energy in some different sort of energy, we use the term joule, we use the unit joule, but the more famous unit of it is calorie. Have you heard of it? Calorie?
Yeah. Yes.
Okay, okay. So the practical unit which we use is calorie, not the joule. Joule is of course SI unit to make like all the conversion easy, because like I said, the heat is the simplest energy which can be converted very easily to other energies. But the problem is all most of the energies are in joule, so it will be convenient to keep its unit as joule when we are talking about the,
Conversion.
but its own practical unit is calorie. Okay, so I'll write,
Kelvin.
for conversion purpose we use joule, but its own practical unit is calorie. So like I said, it's,
Sir, and conversion of calorie to joule and vice versa.
yeah, of course it is possible. I'll be writing just, so its practical unit is calorie. Simply we write it cal. Okay, like joule, so we write it cal. So it is calorie. Calorie. Yeah. Okay. So its practical unit is calorie. Now, like I said, joule and calorie both are the unit of energy, so they must be interrelated somehow. So I'll tell you, the calorie is higher than the joule. Like if you convert 1 calorie energy, how much work you can do? If you get 100% efficiency, suppose you have certain machine which you will give 1 calorie heat. Now how much work it will do? So that work comes as 4.186 joule.
Okay.
So I can say that the calorie is a higher unit, and when it is converted into the work, 100% into the work, this results in this much of joule. So this we have to learn. Okay, so I'll erase it and I'll write what 1 calorie is related to how much work, 4.186 joule, or approximately I can take just 4.18 also. Fine. So this we must remember it. Clear? Everyone, is this clear?
Yes.
Yes, sir.
Yeah. Now let's see what is the 1 calorie. You know that 1 calorie do this much of work. What is actually 1 calorie? How you will define the 1 calorie? Okay, so it is taken as a standard. Like if I say what is 1 meter, so you know on a scale that this much length is 1 meter, let's say, but this has been defined with a certain fundamental things. Okay, so like the same happens with this calorie also, it has a certain definition. What? Suppose I take an example of water. Okay, so if I heat the water by each degree Celsius, if I heat the
Okay.
water by 1 degree Celsius, I'll see we get a different amount of heat each time. So if I pick 1 gram of water, think everyone, if I pick 1 gram of water, I start it heating from 0 degrees Celsius up to certain temperature, let's say 50 degrees Celsius. You know what happens? First, the amount of heat required is high for each degree Celsius. I am plotting the graph for each degree Celsius. Okay, each degree Celsius. Then again it increases. So you see this standard. There is some value, not here. There is some value which gives us the work as 4.186 joule. So this we have taken as a consideration of 1 calorie.
Calorie.
And what is exactly that temperature? It is 14.5 to 15.5 degrees Celsius.
Oh.
This we have to learn.
Sir, but why do we have such U-shaped graph curved?
That depends upon water now, of course. See, it is based on its fundamental properties. Like I said, the molecular structure changes. So each atom, each molecule is affected by all the other molecules in the surrounding.
Yeah.
Okay, so if they are like displaced, suppose you are increasing the temperature, so they will be shifted a bit. Like I earlier said, the shape of object changes. So as you said, this is affected by all the other molecules and they are changing the position. That means there will have some different effect. Okay, so based on that, it becomes easy and tough to heat it up to the next temperature. Okay,
Okay.
yeah, so that's why we get a different sort of curve. It happens with all the objects. Okay, at different temperature, it's not always like okay, this is a very good question. If I say do we need same amount of heat for each degree change, is it correct or not? Like if I say I have a water, I want to heat it from 14 to 15 and there is some 30 to 31, will it require the same heat?
No.
No, that is the point. Good, everyone got this idea? Can someone explain why
Yes.
this is happening? Okay, which one will be more? Just tell me. The water is at 14 to 50 and let's make it 80 to 81. What do you think?
Sir, the 80 to 81 will require more heat.
This will require more heat. That means it is a tough task. Is it so? Someone who is already disturbed, to make it more disturbed, will you require more force?
No.
So see, the temperature is sort of disturbance now. They are
Yeah.
already like wild, they are moving. The molecules are at higher kinetic energy level. Now, if they are already disturbed, to make them more disturbed, you don't need much effort, I guess.
Yeah.
Okay, so someone who is at 100 degrees Celsius and to bring it to 110, of course it is tough, and the same object to bring it 500 to 510 will be easy.
It will be not that much tough.
Okay, because they are already disturbed. So to bring the some sort of disturbance won't be a tough task. Is it clear with everyone?
Yes,
Yes.
sir.
Okay, so this is a very important
Sir.
question. You cannot take that the heat required for same temperature will always be same. No, it will depend upon what is its initial value. Got the idea? So if I say to change the temperature by 10 degrees Celsius, will we require same heat always? No.
No.
For 100 to 110 will be a different. For 500 to 510 will be a different. Yeah, clear everyone?
Yes.
Yes, sir.
Okay, so that's fine. So let's write the definition of then 1 calorie. So what I said earlier, can anyone explain the definition of 1 calorie? I think I explained it. So can someone tell? At least try.
Yes.
Yeah.
1 calorie means work done by an object.
Don't come to the work done, just say about the heat only. It is the
Okay.
heat to do what? 1
To
calorie is
change the state.
to change the
State.
not state. Abhi earlier I said na,
Temperature.
to change the temperature from where to where? I explained taking the example of water na. So based on that, try to explain. It is the heat required to raise the temperature from okay.
14.5 degree to
Okay.
15.5 degree.
Okay, yeah, good. So that's it. You need to remember the values because they are very standard. 1 calorie. Like I said, it is the heat
Required.
To raise the temperature of 1 gram to raise the temperature of 1 gram water from 14.5 degrees Celsius
centigrade
to
15.5 degree.
15.5 degrees Celsius.
Sir,
Yeah.
but how could we take 1 gram of water?
That's a very good question. So you take it 100, later you divide by 100. You take 100 gram, you find out the energy, then you will divide by 100. Okay?
Sir, means what we have to do?
How?
Take 100 ml.
Yeah, means you can take any value, later you divide it with the same value. The
Okay.
result, suppose for 100 ml, you got the heat as 25. So then you divide by 100, the heat will be 0.25, like that. Okay, so to find 1 gram is not tough. You can solve any value, later you divide it with the total amount, it will result in a simple one. Okay.
Yes.
Okay, now we should go into the temperature part then. Okay, so till now what we have covered is what is actually the heat, where it is used, like the total perspective of chapter, what we'll be studying in the whole chapter. Okay, then it's different types, the potential energy and kinetic energy, which are involved with the heat. So the configuration part is involved with the heat, and the motion of molecules is involved with the heat. Motion of molecules we measure with the temperature. So we'll be studying the temperature. Okay.
Sir, doubt.
Yeah.
Sir, then we have placed heat in which column? Potential energy or kinetic energy?
When it's about the temperature change, it has to
We
be
will put it into key.
kinetic energy. And when there is a change of configuration, that means shape change. So let me write it also. Okay, I have related the term temperature related to the molecules, and configuration means it is related to structure. And one more thing, shape of the object. Okay, which is called expansion. Have you heard of thermal expansion term?
Yes, sir. Rubber also.
Yeah, exactly. So uh, this thermal expansion is related to configuration. Okay.
Yeah.
Yeah. One more thing, heat is also known as thermal energy. Okay. So let me write the second term. It is a type of energy which is this and also known as thermal energy. Okay. So heat is also known as thermal
Energy.
energy. Okay. Okay, let's come to the point, temperature. Okay, so to define heat we need what? Temperature, because when we change the temperature of an object we require the heat. That means suppose a temperature is there and different temperature is there, that is happening because of heat. Okay, so to study it what we must be thorough with is temperature first. Okay, so let's discuss what the temperature is. So temperature, anyone, what is the temperature, how you will define the temperature?
The temperature just defines the heat present in any object.
Yeah, heat present in any object, but how you will feel the heat, means is there any feeling term you can say about the temperature? Of course, two simple words are there.
Hot and cold, okay. In simple
Okay.
manner.
Yeah, exactly. So temperature is nothing but it is a measure of this the heat. But to define it, you can say how hot or cold it is.
Hmm.
Okay, so I'll write it in a simple words. It is defined. It is defined as the degree of hotness or coldness. Defined by the degree of hotness or coldness of any object. Okay, though the hot and cold are relative term, though the hot and cold are
Cold are relative.
relative term, that means they are not absolute definition of temperature. Okay, they are relative term. That means suppose a person is at minus 80 minus 40 degrees Celsius, he'll say that the 10 degrees Celsius object is hotter for him, but someone
Okay,
at
that is
15
relativity then.
Celsius, he will see that this is a bit cold.
Colder.
Okay, so of course it is a relative term, so it is just to justify how we can feel the temperature. So this definition is for the feeling of temperature. And what will be its mathematical definition?
Temperature.
Temperature, mathematical definition. What is actually the temperature? It is
Or intensity of heat.
of course intensity of heat, but how we define the heat? As a molecular kinetic energy.
Energy, okay.
Okay, so temperature is one thing is feeling term. This thing is feeling term, and
Feeling.
one thing is sure and mathematical term is to measure the kinetic energy. Okay,
Molecular.
mathematical term is temperature. Temperature is the measure of average kinetic energy. Okay, kinetic energy of molecules. Okay, not the object. मतलब object, if you throw an object you won't see that its temperature is changing or heat is there. Okay, got the idea? So temperature
Yes.
measure of molecular level kinetic energy. Okay, now like I said, temperature. So how we measure this temperature? Of course it is a Like it is a measure of an average kinetic energy, but we can feel it with the hot and cold term. So how we define it means how we define its names, different names.
Sir, means units.
Yeah,
Sir, Kelvin is the SI unit,
yeah,
and Celsius and Fahrenheit are mostly
exactly,
used.
exactly. So we measure it in a different scales. So there are several scales to measure the temperature. There are,
Sir, why don't we measure the temperature of object in Kelvin?
just a minute, okay. So there are several scales to measure the temperature, and we need to study the three major scales, okay. So there are several major uh, scale to measure the temperature. The major ones are, which are the major ones? I guess you already know.
Kelvin,
Kelvin
Celsius,
scale, Kelvin scale. What is the second?
Celsius,
Celsius scale.
and Fahrenheit. Sir, CIUS.
Yeah. What? Celsius, na?
Huh. And Fahrenheit.
And Fahrenheit. Okay, so these are the three major scales we'll be studying, and these scales, the instrument which measures these scale is called thermometer. Okay, so
Yeah.
those also we'll be discussing. So the instrument used to measure the temperature
Is thermometer.
is thermometer. There are different sort of thermometers. Okay, so they have different sort of range. Which sort of thermometer will have?
Sir, I am having doubt.
Yeah.
Sir, why do we say that our body temperature is 36 degrees centigrade, but we never say that that is dash dash Kelvin?
98.6 Fahrenheit.
But we never say in Kelvin.
Okay. No, like it is just depends upon the country now, which system they are going to follow.
No,
Okay.
no.
So
But
what
Kelvin they don't measure only, no?
exactly like I said, see this degree Celsius, most of the thermometer they are designed in a scale this
Yeah.
degree Celsius. Then there is Fahrenheit. So the foreign countries, some Western countries like US, they follow this Fahrenheit temperature. Okay, so it's not like we say 37 degrees Celsius. Have you heard any thermometer which says your body temperature is 37? Have you seen? No,
No, it is generally lesser than
it is always not lesser. It is always in near about 98.6, 99, like that. The all
Fahrenheit.
the thermometers used in India, they tell us the temperature in which unit.
Fahrenheit.
Fahrenheit.
So it's just the point of perspective, like how that thermometer is designed. It is designed to measure what? Okay, so the thermometer used for like medical purposes, they use
They
it.
usually deal in Fahrenheit.
So they totally deal with Fahrenheit scale. So like Kelvin scale, these are used for scientific purposes only. So you won't see like anyone telling you this the body temperature is this. No, they are used for research purposes only. They are, this is the SI unit. This is mainly used for research purposes. Matlab, like if you are solving something, if you are solving on a research one, you will be using all the temperatures in Kelvin, and mainly the Kelvin used for gases. In the study of temperature of gases, we use the term Kelvin more frequently. Okay, so it's not like why we don't use the Kelvin, the body temperature in Kelvin. It's not like that. It is a convenient method that different part of studies they have chosen certain scales, like the medical, like I said, medical they use Fahrenheit, and this researcher purpose they use Kelvin, and the commercial and industrial they choose degree Celsius. Fine.
Yeah.
Yes, sir.
It's not like they cannot use Kelvin, they can use, but it's like already been used in a certain manner, that's why. So no logic is for that. See how there are different sort of thermometers, so we must be familiar with few. The famous one is mercury thermometer, which we use this most of the for body temperature also we use nowadays electrical
Infrared.
used, yeah, but if we say the most conventional one is mercury thermometer, so I'll write few conventional thermometers. So let's say the number one is mercury thermometer. Mercury thermometer. So we need to see what are its range. So usually mercury thermometer can measure up to very high temperatures, like from minus or from not minus from 20 degrees Celsius to 330 degrees Celsius. So usually the mercury thermometers are designed for these ranges. Okay, so of course mercury thermometer are used in industrial purposes also.
Purpose.
Not much temperature is needed. Now where the furnace are used, there we need more sensitive, something which can measure much higher temperature. So and before thermometer there is alcohol thermometer also, but its range are like not that high.
Okay, means not that much effective.
Yeah, exactly, it is near about 50 to 100 110 only.
No.
Okay, there are okay, I'll write alcohol thermometer. So alcohol thermometer.
Sir, it has become alcohol.
Yeah, okay. So alcohol thermometers, they are very sensitive. They are very good for this negative temperature measuring. So they can measure like minus temperature also. So from minus 100 to 50 degrees Celsius. Okay. So these temperatures, of course, mercury thermometer also it is I guess minus 20. Its limit is from negative minus 20 degrees Celsius to 330 degrees Celsius upper limits. So there are many different number of thermometers. Some bimetallic thermometer. Have you heard of this bimetallic thermometer?
Yes, sir, that is like a sort of gun.
Yeah. So bimetallic thermometer, they use this two metals. They use the combination of two metals. So in old age it was used in industrial purposes, bimetallic thermometer. So they use a combination of metals to trigger an alarm when certain temperature is increased. So its limit is quite good. So from minus 50 degrees Celsius to 550 degrees Celsius. So of course they were used in very high industrial purposes.
They are having much range.
Exactly. And then there is scientific purpose and very famous one, radiation. And there are a lot of platinum also. So platinum resistance, it can measure up to 15 degrees Celsius also. All right. platinum resistance. So platinum resistance thermometer. So it has a more wider range from minus 200 degrees Celsius to 1500 degrees Celsius. And there is the last one, radiation pyrometer. Yeah, pyrometer. So this one has the highest range, supposed to measure the temperature of sun. So this is a non-contact object. Okay, so what it reads the radiation from any object. Suppose sun is there, how you will measure the temperature of sun? It's not possible to physically go at the sun, na? So what
then we will measure
radiation of it.
radiation.
So as we know, all the heating objects, they radiate energy. So we measure the energy, based on that we'll calculate the temperature of sun. So based on that radiation, we'll discuss what will be its temperature. So basically, of course, suppose some object is at 100 degrees Celsius, will you able to follow its heat, its radiation? No. 100 degrees Celsius is very less, you won't see the radiation. So the radiations is usually seen beyond like very high temperature, let's say 800 degrees Celsius. Okay.
So then infrared thermometer lies in this only, no? Radiation pyrometer.
Exactly. Radiation pyrometer. They are the infrared are nothing but the radiation sensors only. So they sense the radiation of those objects. So its limit is from 800 degrees Celsius to no limit. हायर का कोई लिमिट नहीं है, एनी टेम्परेचर इट कैन मेजर. Why is that? अभी इन पे क्या पॉसिबल है? They are using a physical element which will be destroyed, okay, which will be in destruction. Suppose temperature is more, this platinum resistance will break, bimetallic strip will fail, alcohol will break. Same happens with the mercury also. But this is nothing, this is actually a calculation. This is not that you are bringing this thermometer in contact with the sun. It's not like that. You are very far away from the sun, you are reading the radiation and you are just calculating what will be the temperature. So because it is a mathematical calculation, there is no limit. Okay. Is it clear to everyone?
Yes.
Okay, so now let's see, as I've explained certain thermometers, let's see the temperature scales. Okay, let's see those famous temperature scales. So temperature scales. So see, all the temperature scales, they have something in common. They must have something in common. So the common thing taken in all the temperature scales is water. What is taken as a common?
Water.
Water.
So you need to remember two things. For each scale, if I say this is like, let's say, if it is degree Celsius scale, so let's say it is Celsius. So Celsius we write in short terms degree Celsius. Okay, where there is Fahrenheit, let's say. So Fahrenheit also we write it degree Fahrenheit. Okay, but to Kelvin we just write K only, not degree. Okay, capital K. So these are scales. So something must be in common. So the common term is used as freezing point of water.
273.
Okay,
Kelvin.
so water freezing point.
273.
Yeah,
Kelvin.
water's freezing point, and there is a reference, other reference, which is boiling point.
Boiling point 373 degrees.
Yeah, good. So in Celsius scale, we already know it. that in Celsius the water is at 0 degrees Celsius. It freezes at 0 and it boils.
Boils at 100.
What is with the Fahrenheit scale then? It freezes at which temperature?
32.
32. Yeah, very good. 32 degree Fahrenheit and it boils at 212
Okay.
Fahrenheit. Okay. With this, it is
Minus
273
273
Kelvin, and of course the higher limit is 373 Kelvin. So you see how many divisions are there between these two, upper limit and lower limit. So you see here are how many divisions are there? 100 divisions. But here you see, just subtract these two values. How many divisions are here?
Sir, in Fahrenheit there are 180.
Yeah, 180 divisions are there. And in Kelvin also there are
100.
100 divisions. So in terms of divisions, the Kelvin scale and Celsius scale are very much alike. Okay, so what should be the common term? Like all the scales, they are using their own numbers. You say these are some scientists, these are three scientists, they wants to use their own number, but something should be kept in common, na? That's why we can use all these. So what is kept in common is called scale constant. Okay, so what is kept in common in these two is scale constant. All right, suppose this is some specific value. We need to find that this is some degree Celsius value. How much will be this in degree Fahrenheit, and how much will be it in Kelvin?
Yeah.
Not degree, just Kelvin. So to express any changes, we need a certain fixed value, that is scale constant. So I'll write the scale constant is for all scales. The scale constant is same for all temperature scales. Okay, and how it is defined? See, scale constant, very simple. Scale constant is defined by a given point. Suppose you want to find the scale constant at 20 degrees Celsius. So that means your given value is what?
20. Sir, then Fahrenheit will be 9/5 into 20 plus 32.
Fine. I'll be going there. Wait. So first, let me explain this scale constant, how it is defined. It is defined by four values. Number one, like I said, given point or given value. So given point minus lower point. Okay. So this freezing point of water is called lower point of each scale. So this is called lower point, and this is called
Higher point.
higher point. This is a reference point. Okay, it's not like Kelvin scale cannot go beyond this. They can go beyond any numbers. It's not like to worry about, but the lower point and higher point are defined based on the water. Okay, so given point minus lower point. Okay, lower point upon higher point minus lower point. Got the idea, everyone? And these are fixed points, higher and lower, these are fixed points. So you can see in each scale the numbers will be same. So I can say scale constant for all scale will be scale constant. See, it will be same for all. Like if I pick Celsius, so I'll do C minus what is its lower point? 0. Minus what is its upper point? 100.
100 minus 0.
Minus 0. This will be also equal to Fahrenheit. Fahrenheit minus what is its lower point?
32.
What is its higher point? 212.
212.
Minus lower point 32. I
Means
can
1.
all these three always. So it is 273 divided by
370 minus 273.
So this will be the scale constant. अभी इनको use कैसे कर सकते हैं? By the way, actual value is not 273. We are taking it as a approximate. The actual value is 273.15 degrees or 15 Kelvin. I'm ignoring the 15.15 term. Okay. So I'll write it here. The exact term is actually 0.15 Kelvin. I'm just ignoring the 15 term. So it is approximately 273 Kelvin only. Got the idea? Okay. Okay. So which means we can relate these three scales anytime we want to convert certain values into some another values. Let's say C by 100 will be F minus 32 over the difference will be 180 is equal to number of division. It will be K minus
273 over 100.
over 100. So these are the scales which we'll be using. Now what we can do, we can divide these things with certain value, certain common. I guess 20 will
Yeah,
be
20.
so we can cut them with 20. So it will remain C by 5. It will be F minus 32 by 9. And it is
And again K minus 273 over 5.
5. So these are easily convertible units. Okay, now you can convert these values anytime, but one more thing, one important term, they are absolute values. They are not like change in temperature. So if you want to keep the change in temperature, change in temperature in any scale, let's say we'll write this a little later. First let's relate some values. Like I said, suppose you want to find Celsius from the Fahrenheit, what we can do then degree Celsius will be, this 5 will be multiplied into 5
9 over
9 times of F minus
32.
or if we want to convert it in Fahrenheit, what we can do, we'll multiply 9 with the C. So it will be 9 by
9 by 5
C plus
32.
32. So we can use it in different terms also. The same can go with the Kelvin also. But the good thing with the Kelvin and Celsius is they will cancel out. Okay. So which means with the Kelvin, it will be Kelvin minus 273 or Kelvin, if you need to find, you can add 273 to the degree Celsius. So these are some changes you can use while solving. So if I say
Sir, then how would we convert Fahrenheit into Kelvin?
the same now, you can take these two, any two, and you can just cross multiply to solve it.
Okay.
I'm not giving the direct formula. These are not like some direct formula you need to remember. What you need to remember is this.
Scale constant.
Yeah, you need to remember all these three relation. Whenever the question is asked, pick two. If question is between Celsius and Fahrenheit, pick two. If question is Fahrenheit and Kelvin, pick these two. Got the idea? Okay, I'll give certain examples, so don't worry about that. You will solve. Okay. Now change is change in temperature. Okay, change in temperature in any scale. So in any scale, change in temperature will be represented as delta C by 5 and F minus 32 is known as delta F, change in F. So it will be 9 and divide by degree Kelvin by 5. So if you want to check the change in temperature, so you can start with there also. You can just see the change in degree Celsius will be 5 by 9 times of Fahrenheit. Okay. Or if you want to find how much the change in degree Fahrenheit will
5
be,
over 5.
9 by 5 of degree Celsius. What about the Kelvin? Kelvin and degree Celsius will cancel out. So degree Celsius is equal to degree Kelvin. Kelvin में change is not an issue. Kelvin and degree Celsius change are same, but to change degree Celsius you need this, or to change degree Celsius into Fahrenheit will be this. Okay, you can always solve for the Kelvin also, the same will be result. So we can just see with the examples. With some examples, I'll see how these skills can be used. So if I say the normal human body temperature is 37 plus minus 0.5 degrees Celsius. Then convert it or express it in degree Fahrenheit and Kelvin scale. Clear? So I guess I can now convert it easily. What we are seeing here, we are seeing these two things. What is the original temperature? It is 37 degrees Celsius plus minus 0.5. What it means
That means we have to take 37.5 and 36.5.
yeah, this is actual temperature. And what is this? 0.
Error.
This is change in temperature. Got the idea that the temperature can change up to these limits. So that means the temperature range will be what? 36.5 to
37.5.
By the way, no need to solve these two difficult values. You can solve alternately because I explained you how to change a temperature and how to change in temperature. Clear?
Yeah.
Yeah, let's start converting it then. So what are the rules for the temperature change? I guess you remember C by 5
Equals F minus 32 over
Upon
9
9.
equals K minus 273 over 5.
Okay, so you can pick any two. Like I said, when you want to convert in Fahrenheit. So number 1, Fahrenheit. So for Fahrenheit, how we'll convert? We'll pick C by 5 and F minus 32 by 9. What is the value of C at this question? 37 degrees Celsius, okay? Now what are the steps to cross multiply it? Done. So F minus 32, I am not multiplying cross this 5, I am just multiplying 9 with the 37.
Yeah.
So it will be 37
into 9 over 5.
5. Now if you solve it, F will be 37 into 9 by 5 plus 32. Okay. So for the exam, you can also recall this, remember it, memorize it. 98.6 degree Fahrenheit it comes. Okay, so the answer is 98.6 Fahrenheit. Now what about the change? What about the change? How we express the change in temperature? Remember the upper part we directly write it delta change
Delta C over 5
is equal to delta F by
F over 9 which
9.
equals
How much is
delta
the change in degree Celsius?
0.5.
0.5 divided by 5 is equal to delta F by 9.
9. But delta F is
0.9.
9.
So the expression of temperature will be then, it will be expressed as 98.6 plus minus 0.9 degree Fahrenheit. Everyone got the idea?
Yes, sir.
Okay, so you need to focus on these temperature also. So if I ask, if I change temperature from 30 to 35, how much will be the temperature change in degree Fahrenheit? So do we need to calculate 30 and 35 both in Fahrenheit scale and then we need to subtract? No. What we can do? Instead, what we can do?
Sorry?
Like the question
has
is,
written 1 and
yeah,
add 0.9.
exactly. We can solve just one at a time. Okay, I'll give it in as an example. Wait. I'll give it in as an example. First, let's complete the part of Kelvin also. Okay. So Fahrenheit we have done. Let's solve for the Kelvin. Now, Kelvin scale. So Kelvin scale, the temperature, we need to use the formula for Kelvin. So C by 5 is equal to
Q by 5. 5 seconds.
C by 5. So 5 are going to cancel. So that means I
Yeah.
already know K can be done with C plus 273.
273.
So it is
So
37.
K equals 37 plus 273.
How much it will be?
70
Sir, 260.
310.
Okay.
Hmm.
So this much Kelvin will be the temperature. Done. And change in temperature. Like I said, delta C by 5 will be delta K by 5. So nothing to worry about. Delta K will be 0.5 only.
Hmm.
So what will be the temperature then? Temperature to express will be 310 plus minus 0.5 Kelvin. Got the idea, everyone? Everyone, okay with this?
Yes, sir.
Yeah. So we need to focus on two things only. Though I have written all the formulas because sometimes they are given in book and you will be asking me, sir, you haven't given this formula, you haven't given this formula. It's not like the formula. The main thing is this. What is the main thing? This. If you remember these three, you can pick anytime, any two, whichever suits you. Okay. If question is related to Fahrenheit and Kelvin, pick these two. If question is Celsius and Fahrenheit, pick these two. If question is Celsius and Fahrenheit, pick these two. Okay. So you need to remember these two things only. This one and this one. Clear? Now, let me give you that example which earlier I was asking. What was it? That suppose an object is heated from 20 degrees Celsius to 60 degrees Celsius, or let's say 84 degrees Celsius, then an object is heated, okay, not this, let's say it is 65. Okay, so an object is heated from 20 degrees Celsius to 65, then find the temperature change caused in degree Fahrenheit scale. Have a problem? You see what is the major problem now? What the students do, they know this formula only. In book you will find this only. Measure of these. In book what you will see? These formulas, okay, related to how to convert Celsius into Fahrenheit or how to convert this. But you won't see this one. Now what happens?
Sir, is that answer 81 degree Fahrenheit?
Yeah, let me see. Let me solve it. So what happens if we change these temperatures? So we need not to find individually as Fahrenheit. So 20 degrees Celsius, we need not to convert it into Fahrenheit, or let's say convert in or let's say convert 65 degrees Celsius in convert in Fahrenheit, degree Fahrenheit. So what is the rule for degree Fahrenheit? We can do C by 5 is equal to F minus 32 by 9. So 9 will be multiplied here and 32 will be added later. So this will be 9 by 5 C in plus 32. So if I solve it, 9 by 5 into 20 plus 32. So what it will be then?
36 and 32 means 68.
68 degree Fahrenheit. Let's convert the second one. So 9 by 5 into C is 65 plus 32. How much it will be then?
117 plus 32. 9. 149.
Okay. Now if I see the change in degree Fahrenheit, what it will be then? We subtract 149 with
68.
68. How much it will be?
81.
81 degree Fahrenheit. So of course this is the correct answer, but what I want to explain is you cannot like use this much time in
So direct I have
question.
put that
Yeah,
difference
exactly. So
9 over 5 into 45.
I'll write in case of change in temperature, no need to solve for individual temperatures. Clear everyone? No need to solve for an individual temperature. You can just directly solve delta C by 5 is equal to delta F by 9. Then delta F will be what? It will be 9 by
9
5
over 5
delta
into
C.
delta C.
So 9 by
9
5
over 5 into
delta C is
45.
65 minus 20,
45.
45. So I can write delta F will be 9 by 5 into
9, 9,
45. So it will be 9 into 9. The answer will be straight. Delta F will be 81 degree Fahrenheit. Got the idea? What is the purpose of that difference formula? So I guess temperature scale, I guess, should be clear now, everyone?
Yes, sir.
Yeah. So I'll give one more idea, one more important note about the temperature scales, that this Kelvin scale is called absolute temperature scales. So sometimes the question can be modified in a manner that suppose the temperature is given like 30 degrees Celsius. What will be it in absolute scale? So now you will be confused what to find. So absolute scale means which scale?
Kelvin.
Kelvin scale, okay? So the Kelvin scale is called absolute scale or absolute temperature. So whenever the question is asked about the absolute temperature, do remember to solve Kelvin scale.
About Kelvin.
Okay, so I'll write here absolute temperature. Okay, absolute temperature. So as the meaning suggests, that the absolute term, so it's not because it is some absolute or something, it is just because what happens in each scale you can find the negative term. In degrees Celsius there is negative possible, so there is one scale in which negative is not theoretically not possible. Okay, so I say negative is possible. All right, negative temperature is negative temperature is possible in all scales like degree Celsius or degree Fahrenheit except Kelvin scale. That means the minimum temperature, the minimum possible temperature is the zero of the Kelvin scale. That means you cannot go negative Kelvin. Okay. Okay, so
Sir,
that means
sir, but why?
The absolute zero is absolute zero temperature is the 0 Kelvin. Okay, absolute temperature is 0 Kelvin or minus 273.15 degrees Celsius. Okay, clear? So in degrees Celsius, in Fahrenheit, you can go up to the negative term, but not in Kelvin scale. That's why Kelvin scale is called absolute scale.
Absolute.
Clear? Clear, everyone? So the Kelvin scale is named as absolute scale. So I'll also write. That's why.
Sir, but why can't Kelvin measure in minus?
Okay, just wait a minute. That's why Kelvin scale is called. That's why Kelvin scale is called absolute temperature scale. See, what are the scales? They are made of, they are made by some scientists. Okay, they are proposed by some scientists. So some scientist took a value. He said like, I'll take the reference water as 0. But later on, we saw that there are certain temperatures which are way lesser than the freezed water, ice. Okay, so then we came to know that there are minus temperatures also. Okay, but there is some scientist who mathematically calculated how much negative is possible. How much higher is possible? It is infinite. The highest in our solar system is of sun, nearly 7,000 Kelvin. Clear? But what is the lowest temperature? He mathematically calculated, and he said that beyond this temperature, this lower temperature is not possible. Beyond this temperature, the lower temperature is not possible. So that's why he said that that particular temperature, which he said that beyond this temperature is not possible, was minus 273 degrees Celsius. So
Sir, but how did he calculate?
yeah, let me say. So that's why he named it as 0 Kelvin. So his scale started with a 0, below which no temperature is possible. Now, how he calculated that I'll name this as a 0. I'll name this as my 0. So like earlier I said, there are certain vibrations of molecules. So what will happen? Suppose if this molecule doesn't vibrate or doesn't move, so all the other molecules will attract it now. When other molecules are attracting it, what happens? It vibrates, it moves in opposite direction, so the attraction force reduces, and again when it comes back, the attraction forces increases. So they are like in a synchronized manner of motion. Now what happens as the temperature drops? What happens with their molecular kinetic energy? It decreases now.
Yeah.
With the decrease in, it's very fine observation. Okay, how Kelvin came to this conclusion? See, as the temperature decreases, kinetic energy decreases. So what he did, he plotted a graph. He plotted a graph that suppose for this temperature you have this kinetic energy, for this temperature you have this kinetic energy, for this temperature you have this kinetic energy. That means there has to be something when your kinetic energy will become 0. Got the idea? So if we extended this graph cut at which point? Minus 273.
Okay.
Got this idea? So then he calculated at this particular point, the kinetic energy of the molecules of these will become 0. But we haven't reached it. Theoretically, no one has reached up to this temperature. Practically, sorry. Theoretically, Kelvin concluded as this the lowest temperature ever, but no one has like reached up to this temperature ever. What will happen at this temperature if the molecules stop vibrating? If there are certain molecules, they are through the vibration they are maintaining what? They are maintaining the particular shape. if suddenly they stops, so if we take a gas and all the molecules, their kinetic energy becomes zero, what will happen with the gas? It will collapse. It will contain no volume. So that means theoretically its volume become what? Zero. That means in a small container you can fill infinite amount of gas. Why? Because all the molecules have stopped and this is not going to occupy any volume. So that's why it is a theoretical term. He just extrapolated the graph. He hasn't reached up to any limit. He just extrapolated the graph and concluded this will be the lowest temperature.
Oh.
Got the idea how Kelvin came to this conclusion?
Yeah.
So everyone clear this? How he concluded? He plotted a graph for a particular gas and he extrapolated that graph and got the value that where
Yeah.
this volume or their kinetic energy will be zero. So I think I should also include this part also. I should write this. The lowest temperature which is minus 273.15 degrees Celsius is the lowest temperature at which a gas is supposed to have zero volume or kinetic energy of its molecules is zero, called the absolute zero temperature. So clear everyone with this absolute temperature thing? Okay. And how we can convert absolute temperature? As we know, this is a Kelvin scale. So absolute temperature, you can just add degree Celsius with 273.
273.
So it will be converted into absolute temperature. So I'll write this is as absolute temperature, which means it is in Kelvin,
Kelvin.
and this is in degree Celsius, or temperature in degree Celsius. Clear?
Yeah.
So I guess up to this point it's clear. So today we have discussed a lot about the theoretical aspect of heat, what is it is going to do, and we also studied the term temperature related to the heat. Okay. In further lectures we'll discuss more about the heat, and of course I'll be asking the question about what I discussed today. So of course do revise the lecture. Okay.
Yeah. Okay.
Okay, till this point, any doubts, any confusion?
No,
No.
sir.
Okay, that's fine then, I guess. Okay, everyone.
Okay, sir. Bye.
Bye-bye.
Bye, sir. Thank you,
That
sir.
question I will
Yeah.
put it
Bye-bye.
on WhatsApp. Two
Yeah, bye-bye.
questions are there.
Yeah, sure.
Bye.
Bye, everyone.
Bye, sir.
Thank you,
Yeah.
sir.